Hey everyone, welcome to Math for the Day. We are going to be focusing on multiplying fractions next. This is actually a two-part lesson. So today we're going to talk about multiplying fractions where we are multiplying a standard fraction by a standard fraction. And I'm going to explain two strategies for that. And then tomorrow we're going to talk about, or not tomorrow, but the next video, we're going to talk about multiplying whole numbers by fractions, multiplying mixed numbers or improper fractions by fractions, and we're also going to include decimals and percentages and what that looks like when we are multiplying by fractions. So today's focus is just the standard fraction by fraction. So you can see that in my title. Before I get started though, what you are going to need for today's note-taking video is going to be your I&B. Again, if you still don't have those, you're probably going to want to grab yourself a good piece of paper that you can take notes on and keep in a safe place. You need two highlighters. I have a blue and a yellow. It doesn't really matter what color they are, but they need to be two different colors. And then you need your pencil. Once you've gathered your supplies, you're going to go ahead and set up your I&B page to look something like mine. I have my title, fraction by fraction. We're going to start by talking about the array model, and then we're going to talk about the standard or shortcut strategy for multiplying fractions. Okay, hopefully you have gathered your materials. Hopefully you have set up your page for note-taking. And now I'm going to walk you through the array model for multiplying a fraction by a fraction. So first what we need is we actually need a multiplication problem. So today we're going to multiply 1/3 times 3/5. So go ahead and add that multiplication problem in there. And we're also going to do the same multiplication problem down here. 1/3 times 3/5. And we'll walk you through that in just a minute. Okay. So what you're going to do is I'm just going to sort of list the steps across the way here, and then I'm going to model it for you over on the right-hand side. Okay, so step number 1 is going to be to draw a model of the first fraction. So draw a model of the first fraction. So if somebody said, draw me a picture of 1/3, I would draw a picture that looks like this. So I have my shape, it's cut into thirds, and now I'm going to select 1/3 of that fraction. So I'm going to go ahead and just highlight 1/3. So you can see this is my model of 1/3. I have a shape, it's cut into three pieces, and I've selected one of those pieces. So that represents 1/3. So this is 1/3. And I'm going to just say 1/3, just kind of draw an arrow, boop, boop. Okay. Then your second step is to draw a model of the second fraction. Okay. And so I'm going to do that. I have some space over here. I'm going to do that over here. So I'm going to draw that a little different here. And this is 3/5. And I'm going to use my other color to show 3/5. 1, 2, 3. And then I'm going to draw a little arrow that just shows that that's what that is. Okay, now what I'm going to do is I'm going to take this model, and I'm going to put them on top of one another. Okay, I'm going to draw a new picture down here. But I want to draw a new model that takes these two pictures and overlaps them. Okay, So we're going to create an array that is denominator by denominator. No, the way to do that is to create an array that's denominator by denominator. So we know that an array, we used the array model when we were learning multiplication in 3rd grade. And so our array for this is going to be denominator by denominator. So that means that I'm going to draw this array here, and it's going to be a 3 by 5 array because 3 and 5. In this case, my denominators are 3 and 5. Okay? And there's my array. My array is a 3 by 5 array. Okay, those are my denominators. Now, I'm going to take the highlighting and I'm going to take the highlighting and I'm going to add the highlighting that I did up here back down here. So my highlighting at the top was 1 like this. And then I had 3 that went like this in my other color. Okay, so now your picture should look like that. Okay? And our little note over here is going to be that we're going to overlap the selected parts. So make sure that basically what we're doing here is we are overlapping the 2 models. Okay, so what we're doing is we're just taking these 2 models and overlapping them together, okay? So now what we're going to do is we are going to, step 4, which is count the total number of parts in the array. Okay, and the total number of parts in the array, this becomes the new denominator. Okay, so my total number of parts in my array, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There are 15 parts, total parts in my array, okay, which becomes my new denominator, okay? It's the new denominator, and it's the denominator of my answer. Okay, and then the last step, my last step is to count the number of parts that are overlapped. That have overlapping highlighter. Okay, so if I go back up to my array up here, the parts that have both colors of highlighter in them, that where the highlighter overlaps, and remember overlap is when something is on top of something else, there are 1, 2, 3 parts that are overlapped, and this becomes the numerator in my answer. Okay, and we'll draw a little arrow all the way up there. Okay, overlap. 1, 2, 3. Okay, all right. So this is a lengthy process, but it kind of explains to you the standard or the shortcut, which I'm going to show you in just a minute. So I'm going to do a so over here. So 1/3 times 3/5 equals 3/15. And if I want to reduce it, I can simplify if needed. And I'm going to take that greatest common factor, and I'm going to reduce it, okay? So it's 3/15. The greatest common factor for 3 and 15 is 3. So I'm going to divide the numerator and the denominator by 3. And that's going 3 divided by 3 is 1. And 15 divided by 3 is 5. And so my reduced answer is this. Okay, so this is the array model. Kind of tricky, but it gives you something visual to look at. Once you figure it out, this is a great way to actually see the answer. So you take your model of your first fraction, and the best way to do this is to use rectangles. Take your model of your first fraction, highlight it so that it matches the fraction 1. This is 1 out of 3 parts. Then make a model of your second fraction. Do the highlighting. This is 3 out of 5 parts, so 3/5. And then visualize taking this and putting it on top of this. So you create an array, which is a 3 by 5 in this case, but you use your denominators to create your lengths for your array, okay? And then you re-highlight, and then you are looking at the total number of parts for your denominator, and then all you're doing is you're looking for the number of parts that have been highlighted in both colors, and in this case it was just 3. And that becomes the product to our fraction times a fraction multiplication problem. And then of course we went through the reducing process using the greatest common factor for the two numbers. Okay. Hopefully, if this doesn't make sense, you can practice it a few times, and then hopefully it will make more sense. Down here, I'm going to show you the standard or the shortcut, the standard algorithm or the standard process for multiplication when we are multiplying a fraction by a fraction. The reason why I call it a shortcut, you'll see here in a minute, is that it is very easy. So I'm going to write 1/3 times 3/5. I want you to note that this multiplication symbol you might also see it as the word of. So I might see this written 1/3 of 3/5. Okay, so I want you to keep that in mind. You also might see the word by. Okay, 1/3 by 3/5. Okay, so what we're going to do is I'm going to show you the standard. So this is really, really quite simple. Step 1 is going to be to multiply the numerator by the numerator. And so I'm going to just set this up right here. So our problem is 1/3 times 3/5 and if I multiply the numerator by the numerator, that happens right here. 1 times 3 equals 3. Okay? Step 2, multiply the denominator by the denominator Okay? And that would be 3 times 5 equals 15. So we just multiplied straight across to get to that, and we multiplied straight across to get to that. And then step 3, reduce. Okay, and we already know up here that we reduced by using the greatest common factor. And I'll even say reduce using GCF, and that is going to equal 1/5. So you can see how easy that is and why I might call it a shortcut. Multiplying fractions might possibly be the easiest operation when we are working with fractions, because you literally are just doing straight across multiplication. 1 times 3 is 3, 3 times 5 is 15, and then we reduce it. Okay, so those are our notes for today. On our next video, we're going to be talking about multiplying irregular fractions, improper fractions, what happens when I multiply a fraction by a decimal, what happens when I multiply a fraction by a percent. So we're going to talk a little bit more about fractions and multiplying with them in our next video. I'm going to leave you today with some practice problems. Today's note-taking video is a little bit shorter than the last few ones that we've been doing. If you did not get caught up on this, I want you to press pause now. I want you to catch yourself up on the notes, and then you can press play when you are done catching yourself up on the notes. Okay, hopefully you're all caught up. I'm going to slide these out of the way. I'm actually going to put my left side page up on the screen here. Reach over and grab a paper clip so that my page doesn't fall over. All right, what I'm going to do with my left side page here is I'm just going to divide my page into 6 parts. So I'm going to go right down the middle here, and then I'm just going to sort of eyeball it and divide my page into thirds. Okay, and then I'm just going to label each section 1, 2, 3, 4, 5, 6. Okay, I'm going to give you 6 different multiplication problems where it's just a fraction times a fraction. I'm going to do the first one with you using both strategies. Then your practice for today is to complete problems 2, 3, 4, 5, and 6. I would say that if you're like, whoa, I am going to use the shortcut for every single problem, that's okay. You need to use what strategy is best for you. But outside of this first problem, I want you to try at least one of the problems using the array model. And then you can check your work by using the shortcut. If you are thinking, wow, I really like the visual of the array model and you want to do all of your problems, you're like, that's how I want to solve all my fraction times a fraction problems. That's great too. I want you to try at least one with using the shortcut or the standard algorithm, okay? Okay, so here are the problems that you're going to do today. So we have 2/5 times 4/7. We've got 1/10 times 5/6. We're going to do 1/5 times 1/7. 1/3 times 7/10. 2/3 of 1/9, and 4/5 of 3/4. Okay. So I'm going to just go through this one up here with you using both strategies. So because my problem's right up here, I'm kind of just going to multiply straight across and use the standard. So 2 times 4, so I'm going to start by multiplying my numerators there. 2 times 4 is 8. 5 times 7 is 35. And I do not think that these, this numerator and this denominator have a common factor. And so I think it's already reduced. So now what I'm going to do is I'm going to come down here and I'm going to draw my array. I'm going to do a 5 by 8. 1, 2, 3, 4, 5, 6, 7, 8. Ooh, good guess. 5 by 8 array, 5 and 8. I'm going to divide my array up by squares. And you'll notice I'm taking out the step where I draw the models separately. You don't have to draw the models separately if you feel like, hey, I can just draw the array using the denominators. And then I'm going to take my blue, and this is my fifth. There's 1/5, 2/5, 3/5. Oops. Made a mistake. At least I caught it. Okay, so now I'm going to take, these are my fifths, 1, 2, 3, 4, 5. 2 of them are highlighted, so I'm going to highlight 2 fifths, 1, 2. And then I'm going to take my yellow highlighter. It says 4 sevenths. Oh my word. Mrs. Erlinson is losing her mind. Sevenths. This does not count. Okay, 4 sevenths, 1, 2, 3, 4, and I'm going to highlight 4 sevenths, 1 seventh, 2 sevenths, 3 sevenths, 4 sevenths, and then my total number of squares, which is really just 5 times 7, is 35, and the total number of squares that are overlapped, 1, 2, 3, 4, 5, 6, 7, 8. Okay. And I got the same answer, so I know that I did my math correctly. All right, so after you're done finishing up taking notes, your assignment today was the note-taking process. I also want you to practice some multiplication problems, and then tomorrow in Google Classroom, you will have your assignment that is based off of just multiplying a fraction times a fraction. There might be a couple of questions on some of the vocabulary that we used, but most of it is going to be you just practicing multiplying a fraction by a fraction. I want you to understand both strategies. There is going to be some questions on both strategies, and so I want you to be prepared for that. Again, as always, if you have any questions, please feel free to pop over to my office hours from 12 to 1 every day, and I will be happy to help you with this strategy if you need help. All right, enjoy your day.